Hello, my name is Zeinab Mohamed. I'm going to start our presentation, and in this presentation, we are going to talk about introduction about bridges, type of trusses, design process, construction process, conclusion, and finally references. Bridges are one of the most ancient structures in the world. At first, they were created naturally, such as stepping stones and fallen trees' legs, which were back then used as passages to pass above rivers. One of the oldest bridges known is the Arcadico Bridge in Greece. It was built around the 13th century. This ancient bridge was built using limestone, bolts, smaller stones, and little pieces of tile assembled tightly together. And surprisingly, it is still in use until today. Nowadays, we have drastic changes in design that allows bridges to carry tons of weight and travels tens of kilometers. One of the most impressive bridges that was built recently is the Millennium Bridge in Gateshead, England. Is known for its grace and engineering as the world's first tilting bridge. The tilt allows the bridge to open for the river traffic to pass beneath, and the tilting takes about 4 minutes.
Hello, this is Sarah Sharafuddin and I will talk today about the types of bridges in this presentation. The structure and development of bridges have changed over the years. With each new type introduced, strengths and weaknesses are introduced as well. While building our bridge, we have researched the relevant types as shown in the figure. The beam bridge, truss bridge, cantilever bridge, arc bridge, tied arc bridge, suspension bridge, and cable-stayed bridge. After plenty of research, we have decided that we ought to build a truss bridge as it is the most convenient and strongest type to meet our objectives. This type is only affected by axial compression and tension, and they are not affected by the bending moment. The most common types of the truss bridges are Warren truss, Pratt truss, Howe truss, and K truss, which I will discuss in a moment. As I just mentioned, I will talk about the most common types of trusses in this presentation. The first type is the Warren truss. This type is made of a series of triangles, whether it's isosceles or equilateral. This arrangement is done to increase the span length of the bridge. The second type is Pratt truss. This type is made of rectangles and one of their diagonals as shown in the figure. In this case, the loads are subjected to the diagonals while the vertical members deal with the compression. The main advantage is that this will increase the efficiency of the bridge. The third type is the Howe truss. This type has a similar arrangement to the Pratt truss as shown. The change of the diagonal changes the direction of the applied force. The last type is the K truss. It is also known as the Parker truss. The main concept in this arrangement is to divide the diagonal members into smaller lengths, which will result in less buckling under the pressure. However, they are rarely used as they are unnecessarily expensive and time-consuming.
Hello, my name is Hagar Magdy. I'm going to be talking about the design process in this presentation. We started the designing process with important decision of picking the type of truss we should use. After plenty of research, we decided to use the Pratt truss to ensure better force distribution and bridge efficiency. After deciding on the truss type, we then moved on to the supports. We decided to build a rectangular support and tweaked the desired dimensions. We designed the sticks on the side of the support to be overlapped, and we had a minimum height of 10 cm. Those photos here illustrate the design of the truss and the design of the supports. While designing the roadway, we needed to stick to the dimensions required, which was a span of 75 cm and a minimum width of 10 cm and a clearance of 7 cm minimum. So we decided that the roadway should consist of multiple layers in a transverse position, and between each two of them, longitudinal layer of sticks. Deciding on the joints was a very crucial point for us, as we're aware that joint failure were very common, so an overlap joint was agreed upon to avoid joint failure as much as possible. Then we decided to use additional supports and add them below the roadway to connect between the trusses and help in carrying the roadway. As for how the load would transfer through the bridge, according to the design, when the bridge is loaded, the load would travel from the roadway to the additional supports, and then through the trusses to the main supports of the bridge.
So we moved directly to the final step, which is executing the idea. Our roadway was mainly consists of 5 layers. 3 of them was in transverse positions, and between each of 2 of them was a longitudinal layer 6. First, we built a 2-layer roadway that was way too flexible, and ended up having a slight bend. So we needed to add more weight to strengthen this and overcome the problem of the bending. And we added more weight to make it rigid because of its length. Now let's move to the trusses. Then if we move to the trusses, we will find that we face some issues with the joints and the strength of the truss. So after finishing the part of the truss, we decided to change the design of the truss. And as expected, the new truss design provided better strength tolerance, and it was slightly more rigid. We first use the truss. What we call this is a brad truss. This is a brad truss. The first truss that was built was not strong enough, as shown in the image, but the second one was so far away rigid and so far away strength. Thirdly, the support is we find our final product was that a rectangular shape, mainly built like layer by layer. For each layer, the sides were built by overlapping stakes in order to obtain a certain required dimensions. But before we go there, at the beginning in the design, we calculated a wrong dimensions, and when we were about to execute, we find out that the supports were smaller than it's supposed to be. So it takes a while. It takes much time than it was expected.
Hello, my name is Alaa Ahmed Hussein. I am going to talk about the constructing process in our presentation, the assembling stage in particular. After successfully constructing the trusses, roadway, and supports, we needed to attach all the parts together. First, we attached both sides of the trusses together using a horizontal 2 structures of sticks. Later on, we added additional supports to connect between the trusses and support the roadway from below. Those additional supports also played a huge role in the load transfer. Second step were to attach the roadway to the trusses and additional supports. And finally, we attached the whole structure to the main supports to complete the body of the bridge. And this image here shows the final product of the bridge. During the whole process of the construction, each constructed part was held using clothespins and paper clips to make sure that the parts stick well together and no slip occur while the glue is drying. This also allowed the final product after drying to have better strength since the pins and clips compressed the sticks together while drying and prevented air from leaking in between. To answer the important question of which part was the hardest to construct, we would have to say that the most difficult part in construction was the trusses. It took pretty long time and a lot of effort in building to maintain accuracy.
Our aim for this project was to construct a bridge that can withstand a minimum load of 100 kilograms, keeping the bridge at the minimum weight possible. To reach our aim, we went through several stages. We started by searching different types of bridges and understanding how their construction work. Then, we started designing the type of the bridge. We agreed on which was the Pratt truss. Once we were done with the designing stage, we started constructing each part of the bridge separately, then assembled all the parts together. We faced many problems in the process, like designing problems, which was mainly dimension errors, and also constructing problems, especially with the truss and roadway. Usually, we needed time to find solutions for these problems. For some parts, like the supports, we needed to recheck and calculate the dimensions, and for other parts, like the roadway and the truss, we mainly needed to strengthen them. From the process of construction, we learned that it is important to recheck our plans. For example, the designs and dimensions before executing them, so resources and time are not wasted. And we are positive that this would help us a lot in the future. As for how this project affected our view on engineering, it showed us how much just studying, memorizing, or solving a problem is not enough to be an engineer. We need to think, to work our minds, to input our own ideas, to make effort, to search a lot, and more importantly, to never give up, no matter how much the topic is unfamiliar and hard, to have determination and to be a real engineer. This is the references we used. Thank you.